Hello, in this video we are going to learn about Internet Transport Protocols, TCP, Transmission Control Protocol. So, introduction to TCP. Back in 1980s, for suppose if you want to transfer an information from a Windows system to an iOS system through a network, there were different networks and standards and computers and operating systems back in 1980s. So, the transfer of information is like bit difficult. To overcome this, a OSI architecture has been implemented. In that, it was in what the TCP was designed to provide a reliable end-to-end byte stream over an unreliable network internetwork. So TCP is a reliable network. TCP was formally defined in RFC 793 in September 1981. Now coming to what is TCP? TCP is a transmission control protocol that defines how to establish and maintain a network conversation through which application programs can exchange data. So we can exchange data by using a TCP network protocol. TCP works with Internet Protocol. TCP and Internet protocols works together, which defines how computers send packets of data to each other. The Transmission Control Protocol is one of the main protocols of the Internet Protocol suite. It originated in the initial network implementation in which it complemented the Internet Protocol. Therefore, the entire suite is completely referred as TCP/IP because they work together. So each mission supporting TCP has a TCP transport entity, either a library procedure, a user process, or most commonly part of kernel. In all cases, it manages TCP streams and interfaces to the IP layer. It is up to TCP to send datagrams fast enough to make use of the capacity but not cause congestion, and to time out and retransmit any datagrams that are not delivered. It is also up to the TCP to reassemble datagrams that arrive in wrong order. In short, TCP must furnish good performance with the reliability that most applications want and that IP does not provide. Now coming to the TCP service model. TCP service is obtained by both the sender and receiver creating endpoints called sockets. Here is the architecture of the sockets, like how they will be working. Each socket has a socket number consisting of the IP address of the host and 16-bit number local to that host called as a port. Port numbers below 1024 are reserved for standard services and they are known as well-known ports. Here are some of the well-known ports. For example, the port number of FTP file transfer is 20. Now coming to the TCP service model. All TCP connections are full duplex and point to point. TCP does not support multicasting or broadcasting. So what is meant by full duplex? In a full duplex system, both parties can communicate with each other simultaneously. An example of a full duplex system is a VoLTE telephone service. And a duplex communication system is a point-to-point system composed of two or more connected parties or devices that can communicate with one another in both the directions. A TCP connection is a byte stream, not a message stream. Message boundaries are not preserved end to end. When an application passes data to a TCP, TCP may send it immediately or buffer it at its discretion. However, at times data need to be immediately sent right away. So to force data out, TCP has a motion of a push flag that is carried on with the packets. One feature of TCP service rarely in use is known as the urgent data. The TCP protocol. Each byte on the TCP connection has a 32-bit sequence number. The sending and receiving TCP entities exchange data in the form of segments.